Okay, so number one gives us a graph of f of x, and they just want us to answer the following questions. All right, so the first one, determine whether this represents an odd or an even degree polynomial. Well, if you look at what's happening at the ends here, if these are pointing in different directions, see how this one is pointing down and this side is pointing up? That tells us that we're going to have an odd degree function. If it was an even degree function, they'd both be opening in the same direction. They'd both be pointing up or both be pointing down. Okay, letter B, determine the sign of the leading coefficient. Is it negative or is it positive? Okay, so to determine that, you only have to look at what's happening as you go to the right on your graph. So if you look on the right, see how that's up? That means that we have a positive leading coefficient. If the right-hand side of this graph is pointing down, then it would be a negative leading coefficient. Okay, so you're only looking at what happens on the right of your graph. Okay, letter C, determine the number of relative maximums. All right, I think about it like this. A relative maximum is really just the top of a bump. It's the highest point in the particular area of a graph. So this right here is a relative maximum, and this right here is a relative maximum. So altogether, we have two of them. If they had asked about relative minimums, it's the minimum point in a particular area of the graph. So you're basically looking for where the graph comes down and heads back up. So right here would be a relative minimum. And also right here would be a relative minimum. But they don't ask for that. Okay, then letter D wants us to describe the end behavior of the graph. Okay, now as far as end behavior goes, for right now, I'm going to say this is always going to be our beginning two sentences. We say as, and you have to write this out, as x approaches negative infinity. Now here I'm saying f of x because that's how this graph is titled. F of x approaches, and we're going to fill this in. And then you would write out, and you have to know how to write this out, as x approaches positive infinity, f of x approaches, and we're going to have to fill this in with something. So this is going to be the beginning of end behavior for all the graphs we do as of right now. All right, all this means is as you go to the left, right, negative infinity, as the x values get smaller, as you go to the left on the graph, what happens to the y values? Well, look, if we look on the left, isn't this graph going down? So we could say that it's reaching negative infinity. And again, you have to write this whole thing out, okay? This is not going to be written out for you because as we progress, you'll see that sometimes this is going to change later on in math. Okay, now this means as we go to the right, as your x values get bigger, we're going to the right on the graph, well, what happens to the y values? Since the graph is pointing up, the y values are getting bigger and bigger and bigger. So the y values are reaching positive infinity. All right, number 2 wants to know which of the following is incorrect. And I would always underline that because sometimes they ask for which is correct and sometimes they ask for which is incorrect. Okay, so choice 1. There is one relative maximum and two relative minimums. All right, well, the relative maximum is the highest point in a particular area. You're actually looking for the top of a bump. This right here is a relative max, and these down here are relative minimums. It's the minimum point in a particular area on the graph. So it's basically where your graph comes down and then starts heading back up again. Okay, when it hits that bottom point, that's your relative min. So choice 1 is correct. Okay, there is one relative max and two relative mins. Okay, now choice 2 wants to know about end behavior. So I just kind of wrote, look at this. As we go to the left, the graph is going up, and as we go to the right, the graph is going up. So this says, as x approaches negative infinity, that means as we go to the left, y approaches positive infinity. The y values go up. That's true. When we look on the left, it goes up. Okay, as x approaches positive infinity, so as we go to the right, the y values go up. That's true as well. As we go to the right, the y values go up. So choice 2 is not the right answer. We're looking for which is incorrect. All right, so choice 3, the degree of the polynomial is even. Remember, if both ends of the graph point in the same direction, see up and up, or if they were to point down and down, that makes it an even degree. So that's also a true statement. So that's not our answer. And then I guess choice 4, but let's just make sure there is a negative leading coefficient. Okay, that's false. Remember, to determine the leading coefficient, you look on the right-hand side of the graph. If it's pointing up, it's a positive leading coefficient. If it were to have point down, it would be a negative leading coefficient. Since this is pointing up, this has a positive leading coefficient, so choice 4 is incorrect. Okay, so that's the answer to this question. Okay, so number 3, they want to know which graph has the following characteristics. Okay, so the first characteristic is it has 3 real zeros. Okay, so we know that a real zero is where the graph intersects the x-axis. So if we look at choice 1, right, there's 1, 2, 3. Choice 2 has 1, 2, 3. Choice 3, even though there's multiplicity here, it still has 1, 2, 3. And the same thing with choice 4. Again, even though there's multiplicity here, right, it bounces off the x-axis, there's still 1, 2, 3. All right, so basically this first characteristic didn't really help us to eliminate anything. So let's look at the end behavior with these next 2 characteristics. Okay, so we know that as x approaches negative infinity means as we go to the left, now this f of x approaches negative infinity means the graph is going to go down. So if we look on the left-hand side, this one's going up, this one's going down, this one's going up, and this one's going down. So we can eliminate the 2 that are pointing up, right? Because it says as we look on the left, it's going down. So it can't be choice 1 or 3. Okay, now this says as x goes to positive infinity, we know that means as we go to the right on our graph, the y values, the function itself, also goes to infinity. So it's going to go up. So as we look on the right on the graph, well, let's look between choice 2 and choice 4. Choice 2 is the one that's pointing up, okay, which is what we want. Choice 4 is pointing down. So choice 4 is out, so choice 2 is our answer. All right, number 4, a sketch of r of x is shown below. An equation for r of x could be, well, let's see, if we have zeros at negative c, negative b, and positive a, then that means we have to have factors. Remember, the factors have the opposite signs, right? So we have factors at x plus c, x plus b, and x minus a. Now, if you remember, since the graph is bouncing off the x-axis, right, it comes down and bounces back up, that means we have multiplicity here. So what we're going to do is we're going to put a square on this factor of x plus c. Okay, there's 2 of them. Whereas at negative b, the graph goes right through the x-axis. And at positive a, again, the graph cuts right through the x-axis. So those don't have multiplicity. All right, so if we look over here, we could see choice 4 is the one that matches up, right? Choice 4 has an x plus c squared, an x plus b, and an x minus a. Okay, so number 5 wants us to find the zeros algebraically. Now, when you do it algebraically, right, what we do is we just set our equation equal to 0 and solve. Okay, so instead of p of x, we're going to make this 0 equals this right here. Okay, so I put my equals 0 on the right-hand side. You could put it on the left-hand side in place of p of x if you prefer. All right, so now let's solve this. So first thing we want to look for is, do we have a greatest common factor? Which out of these 4 terms, no, we don't. So I'm going to jump into factor by grouping. So let's group together the first 2 terms and group together the last 2 terms. Okay, out of the first 2 terms, we could pull out an x squared, which is going to leave us with x plus 1. And of the last 2 terms, well, you could either pull out a positive 4 or a negative 4. But in order to be left with a positive x and a positive 1 in parentheses, we're going to have to pull the negative out of these 2 terms. So I'm going to pull out a negative 4, which is also going to leave us with x plus 1, right? Negative 4 divided by negative 4 is positive 1, so positive 1x. And then, again, negative 4 divided by negative 4 is positive 1. Close the parenthesis, and don't forget to bring down the equals 0. Okay, if it starts off as an equation, you have to keep it an equation the whole time. You need to keep this equals 0. Okay, now, since our parentheses match, we can take what's in front of them, so the x squared minus 4, and we can group those together within one parenthesis. Okay, that's one of our factors for now. And then we could take that common parenthesis, the x plus 1, and rewrite that as our second factor. Now, if you notice, this right here can factor further, okay? This can break into 2 more factors. This is dots. It's a difference of 2 perfect squares. So when that happens, we set up 2 sets of parentheses. One of them gets addition, the other gets subtraction. and we take the square root of the first term and put it in the first spot in each parenthesis. So the square root of x squared is x. And we take the square root of the second term and put it in the second spot in each parenthesis. So the square root of 4 is 2. And then you could just bring down this x plus 1 and it equals 0. And now that everything is fully factored, we can make a t-chart. So here, if you want to do the shortcut method, right, we wind up getting x equals the opposite sign of what we see here. If this is a factor, remember the 0 has the opposite sign, so x equals -2. So over here, we would get x equals, and the opposite sign would be +2. And then x equals -1. Okay, so these are our 3 zeros, our 3 solutions to the equation. And if you want to check, you could substitute each of these numbers in 1 by 1 for x and see if it actually does equal 0. Okay, on the next part, they want us to graph y equals p of x. Now, if these were our zeros when we solved it algebraically, we know that if we were to do it graphically, the graph should cross through the x-axis at those same exact points. So I'm going to start right off by putting an x-intercept at x equals -2, x equals +2, and x equals -1. Okay. If we were to look back at our equation, this thing is dragging along with me. Let's get rid of that for now. If we were to look back at our equation, I just want to point one thing out. See how this right here, our function has a positive leading coefficient? If it has a positive leading coefficient, doesn't that mean that our graph should end up on the right-hand side pointing up? So if it did, that would mean our graph would look something, right? I'm going from right to left. It has to end off pointing up. It should look something like this, right? Like that. So if we were going from left to right, it would go up, down, and back up. But we want to get some more exact points. So I'm going to actually go into my graphing calculator, and I'm going to go to y equals, and I'm going to type in this function. Okay, and when I go to my table of values, I can see these are the points that I'm going to plot. Well, I'm just going to plot the ones that actually fit on this set of axes. Now, I didn't number my set of axes, but if you don't number it, it is implied that each one of these represents 1 unit. So this will be 1, 2, 3, 4, and so on. Okay, now if you notice, look, we have the zeros at -2, 0, right, which is right here, -1, 0, which is right there, and 2, 0, which is right there. So this is checking out from our algebraic work. All right, let's also plot the point -3, -10. Okay, I'm also going to plot the point 0, -4. And then it looks like we would also fit on there this point right here. 1, -6. Okay, and then you can connect them. Okay, so one thing I want to point out is, as long as you graph to the end of your graph, you don't actually need arrows. But if you want to put the arrows, you can. If you don't graph to the end of your graph, like let's say you had stopped, like let's say you went like this and stopped right here, then you would need to put an arrow to show that it continues. Right, the other thing we have to do is we have to label our graph. You don't have to label the whole function. Since it has, function notation, you could just call it p of x. And if you want to write out the whole thing, you can. Okay, so number 6, we want to determine an equation for f of x. Okay, so the first thing we want to look at is where the zeros are. So we have the zeros at x equals 1 and at x equals 8. So what that means is if we have a 0 at x equals 1, we would have a factor at x minus 1. Okay, remember we reverse the sign. And if we have a 0 at x equals +8, we're going to have a factor at x minus 8. Now, let's look for multiplicity. Is there any place where the graph bounces off the x-axis? And look, right here it does. Since it's bouncing off the x-axis, we want to put a square on that factor. Okay, so to start off, what we're going to do is we're going to write out f of x equals, and we're going to put a c there for now. That represents our leading coefficient. And then let's write out our factors. X minus 1 squared times x minus 8. Okay, now in order to determine this leading coefficient c, we need to substitute in a point from our graph. And technically, you can pick any point you want. I mean, other than if you try to plug in one of your x-intercepts, you'll notice you kind of run into a dead end. But if you pick any other point on the graph, that'll help you find the leading coefficient. So I usually like to use the y-intercept. Okay, so the coordinates of the y-intercept right here are 0, 10. Okay, 0 represents the x-coordinate, and 10 is our y-coordinate. And remember, a fancier way of saying y is f of x. So what I'm going to do is I'm going to replace this f of x with a 10. And anywhere I see an x in the equation, in our function there, I'm going to replace it with a 0. So I'm going to replace this x with a 0 and this x with a 0. Okay, so there we have it. We replace the f of x with a 10. Please don't write f of 10. Okay, it's f of x. The y value is equal to 10. And then we replace the x's with zeros. Okay, so let's solve this. So I'm going to bring down the 10. I'm going to bring down the c. And then 0 minus 1 is negative 1, right? But negative 1 squared, a negative 1 times a negative 1 is positive 1. Anything squared is going to be positive. And then 0 minus 8 is negative 8. So if we multiply together negative 1 times negative 8, positive 1 times negative 8, that's going to give us negative 8. So we have 10 equals, you could write c times negative 8, or if you want, you could just write negative 8c. It's the same thing. But either way, to get the c by itself, since this c is being multiplied by the negative 8, the opposite operation of multiplication is division. So we're going to divide both sides of our equation by negative 8. All right, so we get c equals, and I'm going to just simplify this to negative 5/4. If you do want to write it as a decimal, this is equivalent to negative 1.25. So if you prefer decimal form instead, go for it. I'm going to leave it as a fraction though. Okay, so now what we have to do is we have to take this and substitute it in for c back into our original equation, right? And then that is going to be our function. Okay, so again, I took this negative 5/4 and just put it in place of c, see right there, and rewrote the rest of our function exactly like we saw it. I did also write it with the decimal here instead in case anyone prefers it like that. Okay, number 7, super similar to number 6, the one we just went over. Okay, so if you look here, first thing we want to do is we want to pick out the zeros. So we have a 0 at x equals negative 6, and another 0 here at x equals positive 5. So basically, we're going to use those to help us write our factors. So to write the factors, all we do is reverse the sign. So if this is a negative 6, we have x plus 6. If this is a positive 5, we write x minus 5. Now, if you notice, look at this. Here we have multiplicity. Okay, it's coming down and bouncing off the x-axis. It's not cutting through it. And here we also have multiplicity. So since we have multiplicity on both of those, we are going to put a square on both factors. Okay, we have 2 of each of those factors. So when we go to write out our function, now be careful, this time it says g of x. If you write f of x, unfortunately, you do lose a point on a test or whatever for that. So please make sure you keep the function, in the terms it's given. So we could write g of x equals, and then we're just going to put a c to represent the leading coefficient, which we're going to have to solve for in a minute. And then we could just write out our factors, x plus 6 squared, and then x minus 5 squared. Okay, so now we're going to pick a point on the graph, and I usually like to use the y-intercept. Okay, so the coordinates of the y-intercept are 0, 1200. So 0 represents the x value, and 1200 represents the y value. Now, another way of saying y, in this case, would be g of x. Okay, g of x is just a fancier way of saying y. So wherever we see the g of x, we're going to replace this whole entire thing with 1200. Please don't write g of 1200. Okay, this g of x, the whole thing is 1200. Then we could bring down the equals c, and then wherever I see these x's, I'm going to replace it with 0. So we're going to have 0 plus 6 squared, and then 0 minus 5 squared. Okay, and the reason we plug in a coordinate is so that we can solve for c. So let's do that. So let's first bring down the 1200, and then the equals c. And then 0 plus 6 is 6, and 6 squared is 36. Okay, and then 0 minus 5 is negative 5, and negative 5 squared, remember when you square something, it's always positive, is positive 25. Okay, so now what I'm going to do is I'm just going to multiply these two numbers together, and when you do, you get 900. So we have 1200 equals c times 900. Okay, and since c is being multiplied by 900, the opposite of multiplication is division. So to get the c by itself, we are going to divide both sides by 900. Okay, so I'm going to bring down the c, and then basically, those can cancel, right? And 12 over 9 simplifies to 4/3. So this fraction simplifies to 4/3. Now, here's the deal. In number 6, if you wanted to write the c as a fraction or a decimal, it was okay. Because in number 6, if you recall, c was negative 5/4, which is exactly negative 1.25. Now, in this question, right, 4/3, if you plug that into your calculator, it'll give you 1.333, and it just keeps going and going and going. Now, I know we've learned in previous years that's equivalent to 1.3 with a bar over it, right? But I don't want you to write it like that in the function, because if you wanted to, let's say, go in your calculator and graph this, you can't plug in a 1.3 bar into your calculator. So if you ever get a decimal like this that keeps going and going and going, just leave it as a fraction, okay? And if you're not sure how to write that as a fraction, you can always use your calculator, plug in 1200 divided by 900, and if you hit math, enter, it changes it to a fraction for you. Okay, so what we have to do now is we have to take this 4/3 and substitute it back in for c. So we're going to substitute it back in right here. Okay, so when you do, this is what we get. We rewrite this original function exactly like we see it, but you replace the c with what c is equal to, 4/3. Okay, so number 8 wants you to sketch a possible function of p of x. Now, it does say where a, b, and c are positive. All that means by saying a, b, and c are positive is that they want you to keep the signs that are there. Because think about it. Let's just say a was negative. See how there's a negative in front of this? Wouldn't a negative become a positive? So basically, all they're telling you by saying that it's positive is that you're going to keep the signs that are there. Okay, so let's first look what we have. We see that we have factors at x minus b and at x plus c. So if we have a factor at x minus b, doesn't that mean we have a 0 at x equals positive b? So you could put b wherever you want. I'm going to put b right here. Here's my b. So I'm going to put a 0 right there. Okay, just put a point right on the x-axis. And again, if we have a factor at x plus c, doesn't that mean that we have a 0 at x equals negative c? So I'm going to put negative c wherever you want on the negative portion of the x-axis, and we could put a point there. Okay, now let's think about this. We only have 2 zeros, okay? Right here at this 0, see how it's squared? It means we have multiplicity. It means it's going to bounce off the x-axis. So it's either going to bounce this way and come back up, or it's going to bounce this way and come back down. Now, since our leading coefficient is negative, what it means is it's going to end off coming down. So if it's going to end off coming down, right, and it has to bounce off the x-axis at b, I'm basically going to draw a graph. I'm going to work from right to left. that looks like this, okay? It's going to bounce off. Now at negative c, there's no multiplicity. It's going to cut right through. So it's going to cut through like that. So this is what our function is going to look like. Okay, it has a negative leading coefficient, so it has to end up pointing down. It bounces, since there's multiplicity, a square bounces off the x-axis at positive b. And since there's no multiplicity here, it's going to cut through the x-axis at x equals negative c. Oh wait, I almost forgot. We also, in addition to our arrows, right, to show it keeps going, we also have to label it. So you could label that p of x. All right, the next one. It wants to know which of the following is not a factor of the polynomial. Now, if you try to factor this by hand, right, you'd have to do grouping. And what you'd notice is if you factor an x squared out of the first two terms, it leaves you with x minus 10. And out of the next two terms, the only thing you could factor out would be a 1, which does not leave you with an x minus 10. So they don't actually want you to do this one through factoring. I'm going to erase that. What they're looking for you to do is look at the graph of this function, plug this into your calculator, and look at the zeros, determine the zeros, okay? And from there, we know we just reverse the signs to find the factors. Okay, so I know a lot of pictures just kind of popped up on the screen here. Now this first one, what I did was I went to y equals in the calculator, and I typed in this expression, okay? So we're graphing this function. When you hit graph, you could see this is what the graph looks like. So it looks like it crosses through the x-axis at x equals negative 1, at x equals positive 3, and at x equals 8. Now, even if you weren't exactly sure, even if you couldn't tell from the graph, you could hit second graph. You can go to the table of values, and you could see, look, right here, at negative 1, the y value is 0. Okay, so at x equals negative 1, that's a 0. At 3, when x equals 3, the y value is 0, so x equals 3 is a 0. And then if you scroll down a little more, when x equals 8, the y value is 0. So these are our 3 zeros. Now we know the factors have the opposite sign. So the factor that corresponds with this would be x plus 1, so we can cross off choice 4. The factor that corresponds with x equals 3 would be x minus 3, so we could cross off choice 1. And then the factor that corresponds with x equals 8 would be x minus 8, so we can cross off choice 3. So choice 2 would be the one that is not a factor of that polynomial. Okay, so number 10, which of the following has a factor of x plus 8? Okay, so what they want you to do is something similar to number 9. They want you to graph each of these one by one in your calculator, so you're going to do it one at a time. And if we have a factor of x plus 8, doesn't it mean that the graph should cross through the x-axis at x equals negative 8, right? We should have a 0 at x equals negative 8. Okay, so I'm going to, rather than graphing these one by one, I'm going to jump right to the answer. So, okay, so when you get to choice 3, right, when you type that into y equals and hit graph, this is what the graph looks like. So you could see at x equals negative 8 right here, the graph is crossing through the x-axis. So this is going to be our answer. If you want to just double check to make sure that is at x equals negative 8, go to your table of values, right, second graph, and you'll see, look, at negative 8, the y value is 0. So we have a 0 at x equals negative 8. Okay, so choice 3, this right here, is your answer. Okay, number 11 wants us to find the zeros. Now, I'm going to do this algebraically, and then I'm going to check it graphically. So if we want to do it algebraically, in order to find the zeros, all you do is you just take this expression right here and set it equal to 0. Okay, so what we're going to do is we're going to factor and make a t-chart. Now, when you look at this, the first thing you'll notice is that every single term contains an x. So we're going to factor out the greatest common factor of an x, which is going to leave us with x cubed minus 4x squared minus 9x plus 36 in parentheses. And then make sure you bring down the equals 0, okay? If it starts as an equation, you have to keep it an equation the whole way through. So basically, when we factored out an x, basically each of these x ones, look at that, they just went down by 1 because we took an x out. Now, I want to look in here and say, well, can I factor further? Since there's 4 terms, we are going to do grouping. All right, it looks like I'm going to have to write on top of the next problem, and then I'll just erase it. Okay, so I'm going to take this x and bring it down. And I'm going to bring down this parenthesis. Okay, now, out of these first 2 terms, I can pull out an x squared, which is going to leave me with, in parentheses, an x minus 4. Okay, close up those parentheses. Now, out of the next 2 terms, I have to decide, well, do I want to factor out a positive 9 or a negative 9? Well, if I want to be left with x minus 4 in parentheses, it looks like I'm going to have to factor out the negative 9. If on accident you factor out a positive 9, you'll notice the parentheses don't match, and then you just switch it up. So I'm going to factor out a negative 9 out of these 2 terms, which will leave me with a positive x, and then 36 divided by negative 9 is negative 4. So now I have to close up this parenthesis as well as, we opened one here, we have to close that one up as well. And then you can bring down the equals 0. Now this is good because the parentheses match up, so it means, everything's going right so far. All right, so let me first bring down this x on the outside of the parentheses. That's going to continue to come down. And then within my first parenthesis, I'm going to group together the terms that are in front of the common parentheses. So I'm going to group together the x squared minus 9. And then I'm going to bring down that x minus 4, that common parenthesis, just once. And we could also bring down the equals 0. Okay, now if you look here, doesn't this factor further, right? This is dots. So this is going to factor to x plus 3, and then x minus 3. And then I'm going to take this x and bring it down. I'm going to take the x minus 4 and bring it down. And let's bring down the equals 0. And I just want to backtrack a minute. If you forgot how to factor this using dots, right, it's a difference, and both of these are perfect squares. So that's where we set up 2 parentheses, one gets addition, one gets subtraction, and the square root of this first term goes in the first spot in each parenthesis, and the square root of the second term goes in the second spot in each parenthesis. And at this point, we can make our t-chart and solve. Okay, so when we set this equal to 0, there's really nothing to solve. We get x equals 0. Now, rather than setting each one of these equal to 0 individually, we could just jump right to the zeros, right? We know if we have a factor of x plus 3, doesn't the 0 have the opposite sign? You would get x equals negative 3. If we have a factor of x minus 3, the 0 will have the opposite sign, so x equals positive 3. And same thing here, this would be x equals positive 4. So we wind up with 4 values of x that hold true in this equation, okay? These are considered our zeros. And it makes sense, because if we have x to the 4th power, we're going to have up to 4 answers. The only way we don't have 4 answers is if one of these has multiplicity of 2, if the same answer shows up twice, okay? So that is going to be choice 1, right? We have 0, positive and negative 3, as well as 4. 12, when factoring to reveal the roots of this equation, which equations can be used? Okay, so I think what I'm going to first do is I'm going to take the original equation and factor it. Okay, so I want to say to myself, can I pull out a greatest common factor? Which I can't, so I'm going to jump right into grouping. So out of the first 2 terms, we could pull out an x squared, which in parentheses leaves me with an x plus 2. And out of these next 2 terms, we could factor out a negative 9, which leaves me with also an x and then a plus 2. Okay, now we're going to take what's in front of the common parenthesis and group them together within a parenthesis. And then I'm going to take the common parenthesis and write it just once. Okay, and then this right here is a difference of perfect squares. So we can factor that further using dots. So 2 sets of parentheses, one gets addition, one gets subtraction, And the square root of x squared is x. And the square root of 9 is 3. And then we'll bring down the x plus 2 and the equals 0. Now, I'm not actually going to make a t-chart and factor because I don't think we have to do that to answer this question. They just want to know which of these can be used to solve this. So technically, we should wind up with the same thing here in whichever ones are equivalent. Okay, so let's start with the first one. So, I mean, look at this. If you have, see how these parentheses are common? Can't we take what's in front of them and group them together within a parenthesis? So we'll take the x squared minus 9, and we'll group that together in a parenthesis. Right, this is kind of like the middle step of factor by grouping. And then we take the common parenthesis and we write it once and once only. And bring over the equals 0. Now, technically, I could factor this further, right? But look at this. Doesn't this right here say the same thing as this right here? So if I did factor further, I'd wind up with the same thing. So choice 1 checks out. All right, let's try choice 2. So choice 2, we'll do over here. Again, if these parentheses match, we could take what's in front of them, so the x plus 2, and we can group that together within a parenthesis. And then I could take that common parenthesis, the x squared minus 9, and rewrite that once and bring down the equals 0. Now again, although I can factor this further, I'm not even going to bother because, look, we have an x squared minus 9, which is what this says, and we have an x plus 2, which is what this says. Technically, these say the same exact thing, just in a different order. And when you multiply, it doesn't matter what order you're in. So this one checks out as well. All right, now choice 3. Well, I could see right off the bat that's not going to work. Because although we have the x squared minus 9, this says x minus 2, and this one says x plus 2. So this one right here, choice 3, is a no-go. So choice 1 and choice 2 both check out. So it looks like it is going to be the first one, 1 and 2 only. All right, number 13 says to factor. All right, so whenever we factor, the first thing we want to say to yourself is, can I pull out a greatest common factor? Is there something that divides evenly into all 3 of these numbers? Well, yeah, they're all even, right? So we could pull out a 2. And you do want to look and say, can I pull out anything bigger than a 2? But in this case, you can't. You also want to look and say, can I pull out any variables? But because this last term does not have an x, we're not going to be able to pull any out. All right, so we're going to pull out a 2. Now, whenever you factor out a greatest common factor, you only open up one big parenthesis, okay? You don't open up 2 sets of parentheses. And basically, we're just going to divide each of these numbers by 2. So 12 divided by 2 would be 6, so we have 6x squared. Negative 38 divided by 2 would be negative 19. We'll bring down the x. And then 20 divided by 2 would be 10. Okay, so now we're going to look at our trinomial, right? Tri means 3. And we're going to say that we're going to see that because the number in front of the first term is something other than a 1, this is when we're going to do the rainbow. So we do not set up 2 sets of parentheses underneath this, okay? What we do is after we bring down the 2 and open a parenthesis, we bring down our first term, we leave a big space, we bring down our last term, and we're going to come up with 2 numbers that multiply to 6 times 10, so multiply to 60, and then add to negative 19. Okay, if they multiply to a positive, right, if they multiply to positive 60, we know they have to have the same signs. But since they add to a negative, we know both of those signs are going to be negatives. So we're going to have a minus and a minus. All right, so the 2 numbers that multiply to 60 and add to negative 19 would be what? Negative 15 and negative 4. So we have a negative 15 and a negative 4. And because this middle term has an x on it, we're going to attach an x to each of these. All right, so now we can bring our 2 down, and we're going to start the process of grouping. So we group together the first 2 terms, and we group together the last 2 terms. So out of these first 2 terms, we can pull out a 3 as well as an x. And when we pull a 3x out of those 2 terms, it leaves us with 2x minus 5. Now, out of the next 2 terms, you have to decide, do you want to pull out a positive 2 or a negative 2? Well, since within this parenthesis, the sign goes positive, negative, and up here the signs do the opposite, negative, positive, we want to pull out a -2. That way we'll wind up with the same thing in parentheses. So again, if the expression here has the exact opposite signs of what we see up here, right? Positive, negative, negative, positive, that tells you to factor out a negative. So I'm going to factor out a -2 instead of a +2. And that way, -4 divided by -2 is +2. So I have positive 2x. And then positive 10 divided by -2 would be -5. And you can see our parentheses match, which we want. So what we're going to do is after we bring down this 2, we're going to group together in the first parenthesis what's in front of our common parentheses. So the 3x and the -2. Okay, that's what's in front of our common parentheses here. So 3x minus 2 goes in one parenthesis. And then you can rewrite the common parenthesis once and once only. And that right there is fully factored. And what I want to just point out, when it says factor, okay, you factor and stop. This is not an equation. It doesn't have an equals 0 at the end. It doesn't say find the zeros. So please don't try to make a t-chart and solve. This is it. This is factored. It's an expression, not an equation. Whereas when you look at number 14, see how that's an equation? That we're going to solve. So let's take a look at number 14. All right, now in order to solve that, the first thing we want to do is we want to set our equation equal to 0. So I'm going to just add, I'm just going to add 26x to both sides, and that way the right-hand side of the equation will be equal to 0. I'm going to line that up under this middle term here. That way I can combine my like terms. So I'm going to bring my 10x squared down. And then I'm going to combine my like terms. Negative 2x plus 26x would be positive 24x. And then I'll bring down my plus 12. And then equals 0. Now here's the deal. You could do one of two things. You could factor out the greatest common factor, which is 2. Or when you have an equation, as long as the greatest common factor is just the number, right? If it's a variable, this doesn't work. If it's just a number, you can actually, instead of factoring it out, you can divide both sides of the equation by that number, and then it gets rid of it altogether. So 10 divided by 2 is 5, so we have 5x squared. 24 divided by 2 is 12, so we have plus 12x. And then 12 divided by 2 is 6, so plus 6. Equals 0. Okay, 0 divided by 2 is 0. All right, so now we have a trinomial. In order to solve this, we could do one of three things, really. We can try to factor, make a t-chart and solve. We can use a quadratic formula, or we can do completing the square. Now, here's the deal. If you try to factor, because there's a number other than 1 in front of the first term, you'd have to do the rainbow. And 5 times 6 is 30. Now, there are no two numbers that multiply to 30 and add to 12. So this cannot be factored. So personally, what I would recommend is if this can't be factored, I would personally use the quadratic formula. If you like completing the square, go for it. I think this would be kind of a difficult one to do by completing the square because you have to divide everything by 5 and have all these fractions involved. So personally, I'm going to use the quadratic formula. Okay, so here's our quadratic formula. This is the formula itself, and our A is 5, our B is 12, and our C is 6. So I just wrote that off to the side. So what I'm going to do is I'm going to take these numbers and just substitute them in to the formula. So we'll have x equals, I guess I'll do that over here, x equals, so negative b, so negative 12, plus and minus the square root of b squared, so 12 squared. Now, because it's positive, you don't have to put this 12 in parentheses before you square it, but if it was negative, you would need parentheses like that. But if you put them in, if it's positive, it doesn't hurt. Okay, minus 4 times a, which is 5, times c, which is 6. And that whole entire thing, make sure you extend the fraction bar from the beginning to the end, is going to be over 2 times a, so 2 times 5. And one thing I want to point out, this x equals is necessary. If you do not write x equals, that will be a point off. See how this is an equation? See equal sign, equal sign, equal sign? This equal sign needs to be there the whole entire time. Like, believe it or not, this equation is equivalent to this equation. This is just what we get when we're getting x by itself when we're solving for x. So the x equals is super necessary. Okay, so I'm going to bring down the x equals, and we have negative 12 plus and minus, and then you just have to figure out what that's equal to into the radical. 12 squared minus 4 times 5 times 6, you end up getting 24. And that's going to be over 2 times 5, which is 10. Okay, now, we know we are not allowed to simplify these two numbers until we have first simplified the radical, broken that down, right? Because technically there's a 1 in front of this radical, and you're only allowed to simplify these numbers if you could simplify the number in front of the radical as well, and we can't. So off to the side here, I'm going to break down the radical 24. Okay, so the biggest number that divides evenly into 24 that's a perfect square would just be 4. So I'm going to break this up into radical 4 times radical 6. And since the square root of 4 is 2, we get 2 radical 6. Okay, so I'm going to rewrite this, and where I see the radical 24, I'm just going to replace it with a 2 radical 6. So that's the only thing I'm doing at this point. I'm just replacing radical 24 with what it's equivalent to. Now that we have a number in front of our radical that isn't the 1, now we could look at all three numbers and say, well, what divides evenly into all of them? Well, 2 does, right? So if I divide them all by 2, negative 12 divided by 2 is negative 6. 2 divided by 2 is 1. So you could write 1 radical 6 or just radical 6. And by the way, please don't try to divide the number under the radical by 2, okay? That's not a 6, that's a radical 6. That's equal to a decimal. So, 2 point something. So please don't try to simplify that. And then to finish off, 10 divided by 2 is 5. And that right there is our answer. All right, so number 15 asks us to solve for m. So in order to solve this, whenever we have an exponent involved, right, we want to get one side of the equation set equal to 0. So in order to do that, I'm going to just subtract this 2m right here from both sides of the equation, and that way we'll just have the right-hand side of the equation set equal to 0. All right, so we know on the right-hand side that cancels out, and it's equal to 0. Now, nothing here is like terms, right? That's an m squared, that's an m, and that's just a number. So we're going to just kind of bring them down, but make sure you write it in standard form, which means you have the term with the biggest exponent first, so the 2m squared, then the one with the next biggest exponent, right, minus 2m to the first, and then the number by itself at the end. Okay, that one has m to the 0, no m's. All right, now, since it's a trinomial, right, we could try to do, in order to solve this, we could try to factor and make a t-chart. We could use the quadratic formula, or we could do completing the square. Now, if you do try to factor this, right, because there's a number other than 1 in front of our first term that doesn't factor out, we'd have to try to come up with two numbers that multiply to negative 22 and add to negative 2, which doesn't work. So just like the last one, again, because it doesn't factor, I recommend using the quadratic formula. If you want to do completing the square, you can, but I think it's going to make your life a little bit harder. Okay, so let me just write the quadratic formula off to the side. Okay, so first of all, notice that I wrote m equals, not x equals, because we're solving for m. Our a is 2, our b is negative 2, and our c is negative 11. So I'm going to take these numbers and just plug them right into the quadratic formula. All right, so again, make sure you write m equals. If it starts off as an equation, right, equal sign, you need an equal sign before you plug things into the quadratic formula. Okay, so it's going to be negative b, so negative 2 is going to be positive 2. If you want to write negative 2 and change it later, you can, but I personally just like to write positive 2. And then plus and minus the square root of, now if you write it like this, negative 2 squared, unfortunately, you're going to wind up getting the wrong answer. That's not correct. You want to make sure that when you square a negative, you always put the negative number in parentheses. And then minus 4 times a, which is 2, times c, which is negative 11. Let me extend this a little further. And then your division bar should extend from the very beginning to the end of that numerator. And that's going to be over 2 times a, so 2 times 2. All right, so let's bring down the m equals positive 2 plus and minus. And then we can figure out what that's equal to under the radical, which is 92. And that whole thing is going to be over 2 times 2, which is 4. Now remember, please do not try to simplify just the 2 and the 4, because you have to also be able to simplify it with the number that's in front of the radical, which is a 1. And 1 is not going to simplify. So what we do first is we break up this radical, and I'm going to do it off to the side. All right, so the biggest perfect square, actually the biggest perfect square that divides evenly into 92 is 4. 92 divided by 4 is 23. So I'm going to break that up into radical 4, radical 23. And since the square root of 4 is just 2, that simplifies to 2 radical 23. So I'm going to replace this radical 92 with a 2 radical 23 in our equation here. Okay, so now that we have a number in front of our radical, now we can look and say, right, you can only simplify all 3 of these, not 2 out of 3 of them, all 3 of them. So you want to look and say, well, what's the biggest number that divides evenly to all 3 of them? 2 is, right? So 2 divided by 2 is 1. Same thing here, 2 divided by 2 is 1, and 4 divided by 2 is 2. So we're going to change these to a 1, and a 2. So m equals 1 plus and minus. Now you could either write radical 23 or 1 radical 23. It means the same thing. So if you don't want to put the 1 here, you don't have to. You could just write radical 23 over, and then 4 divided by 2 is 2. But I want to point out this 1 is needed, okay, because that's the only thing in front of the plus and minus. If you didn't write it, wouldn't that mean 0? Whereas if you don't write the 1 here, it still implies that there's a 1. So we have 1 plus and minus radical 23 over 2. All right, now number 16 asks us to solve this equation, and I want to, let me see if I have a highlighter here I can use. I want to highlight something that's very important. It says in simplest radical form. Now that's basically a clue that's coming out and telling you you will need to use the quadratic formula or completing the square if you prefer. If you're going to have a radical in your answer, what that means is that's not going to factor nicely for us. So you don't have to spend the time to try to factor that. That's not going to factor for us. Okay, so here's our quadratic formula, and our a is 6, our b is negative 2, and our c is negative 3. So I'm going to take these values and substitute them in. All right, remember, it's super important to write x equals. So we get x equals, right, you want to keep it in equation, negative b. So negative 2 is positive 2, and then plus or minus the square root of, and remember, when you plug in a b here, if you square a number that's negative, this has to go in parentheses, okay? This is not correct, okay? That's equal to negative 4. Here, when you put it in parentheses, that's equal to positive 4, okay? Totally different value. All right, and then we have minus 4 times a, which is 6, times c, which is negative 3, and that whole entire expression is going to be over 2 times a, so 2 times 6. All right, so we have x equals 2 plus and minus the square root of, and that is equal to 76 over 12. Okay, so remember, at this point, we cannot simplify these two numbers, right? We can't make it like, say, 1 over 6. Because you have to also be able to simplify the number in front of the radical, and that's a 1, okay? And a 1 doesn't simplify. So let's first take this radical and break it down. I'm going to do that off to the side here. So the biggest number that's a perfect square that divides evenly into 76 is 4. And 76 divided by 4 is 19. So we're going to break that up into radical 4, radical 19. And since the square root of 4 is 2, that becomes 2 radical 19. So I'm going to go back to my original equation over here. X equals 2 plus and minus. And where I see the radical 76, I'm going to replace that with 2 radical 19. Okay, and that's going to be over 12. now, oh, that's a messy 12. Now we could look at all three of these numbers and say, look, the biggest number that divides evenly into each of these is 2, so let's divide them by 2. So when we do that, leaves us with 1 plus and minus 1 radical 19, which is the same thing as radical 19, over 12 divided by 2 is 6. And that is it. That is our solution. Okay, now number 17 says to determine the zeros, right? So the zeros, we could set this equal to 0 and solve. Or if you wanted to try it graphically, if you go to y equals in your calculator and plug in the equation and hit graph, what you'll notice is, first of all, this is the 5th power, so there can be up to 5 solutions, right? By looking at this graph, I honestly can't tell what the 5 solutions could be. So doing this graphically is not going to be beneficial for this example. So I'm going to get rid of these graphs, and we are going to try this algebraically. Okay, so basically, to do it algebraically, all we do is we just set this equal to 0. So I took this and set it equal to 0. Now, if you look here, you can see that we could factor out a greatest common factor. Okay, we could pull a 2 out of each term as well as an x. Now, if you wanted to divide this entire equation by 2, you could. But you can't, unfortunately, divide by 2x. You don't want to ever divide by a variable, because what happens is when you divide by a variable, it eliminates one of your answers. It actually causes that to become a 4th degree function instead of a 5th degree. So what I'm going to do is whenever a variable is part of the greatest common factor, I'm just going to factor the whole thing out, which leaves us with x to the 4th minus 17x squared plus, sorry, that's supposed to be a square, 72 equals 0. Okay, now we're going to look at this trinomial and say, well, can I factor further? Because there's a 1 as our leading coefficient, please don't try to do the rainbow and to factor by grouping. That's just extra unnecessary steps. So what we're going to do is, whenever we have a trinomial where the leading coefficient is a 1, we just set up 2 sets of parentheses. And we're going to do the AN method. We're going to find 2 numbers that add to this middle term, so add to negative 17 and multiply to 72. Now, before we do, if this is an x to the 4th, what that tells us is we're going to put an x squared in the first spot in each of these parentheses, because x squared times x squared gives us x to the 4th. And then 2 numbers that multiply to, if they multiply to a positive, right, they have to have the same signs. And since they're adding to a negative, I guess those signs have to be negative, right? And the 2 numbers that multiply to positive 72 and add to negative 17 will be negative 9 and negative 8. Okay, so if you notice, this right here is a difference of 2 perfect squares. Okay, we call that dots. So I'm going to factor that further. So let me bring my 2x down, and I'm going to factor the x squared minus 9 further to, let's see, first parenthesis gets addition, the second gets subtraction, or vice versa, it doesn't matter. The square root of x squared is x, so we'll put that first, since x squared comes first. And the square root of 9 is 3, so we'll put that in the second spot in each parenthesis, since the 9 came in the second spot in that parenthesis. And then this doesn't factor further because 8 is not a perfect square, right? Nothing times itself gives you 8, so I'm just going to bring that down. All right, now that we're fully factored, let's make a t-chart and solve. Okay, so if I take this first factor and set it equal to 0, I mean, I'm sure a lot of you could just say in your head, well, 2 times what gives you 0? 0, so x has to be 0. If you want to show the work, you could show that to get the x by itself, we divide both sides by 2. So that leaves you with x equals 0. Okay, that's our first solution. Now here, when you have a simple factor like this, right, don't we just reverse the sign, x equals negative 3? And for this one, you would get x equals positive 3. Okay, so those are our next 2 zeros. And then over here, I'm going to actually take this equation and set it equal to 0 and solve. So to solve, I'm going to add 8 to both sides of the equation, which leaves me with x squared equals 8. Now, this squared tells us that we could have up to 2 answers over here. So when I take the square root I get x equals positive and negative, right? That's what accounts for the two answers. Now, this is not a perfect square, but what we need to do is we need to simplify that radical as much as possible. So you can break down a radical 8 into radical 4 times radical 2. And then since the square root of 4 is 2, this will become plus or minus 2 radical 2. Okay, so altogether we have 1, 2, 3, 4, 5 answers. And this fifth degree told us we could have up to 5 answers. By the way, guys, that says negative 3. That's a little negative sign. I know it's kind of connected to the 3 there. Okay, and then finally, let's take a look at number 18. Okay, so this one tells us to algebraically determine the zero. So that means we have to set this equal to 0 and solve. And then when we're done, we're going to check our answers graphically. So we're just going to, sketch a graph of this and make sure that the zeros we get are the same things as the x-intercepts of our graph. Okay, so first thing I want to point out, this is not in standard form. Okay, and there are like terms that we could combine. But usually when you start off with an expression with 6 terms, usually you're going to try to see if you can jump right into grouping and come up with the answer. Usually you don't have to rearrange things. So we're either going to group this into, we have to decide, do we want to group it into 3 groups of 2, or do we want to group it into 2 groups of 3? Okay, I'm going to first try the 3 groups of 2 since that's what I have up there first. Let me erase this. And let's see how we do. Okay, so out of these first 2 terms, I could pull out an x squared, which is going to leave me with x squared minus 4 in parentheses. Okay, out of the next 2 terms, I'm going to pull out a positive 8 as well as an x, so plus 8x. And that is also going to leave me with the same thing. So this is how we're going to want to group it. Okay, if I pull an 8x out of 8x cubed, I still have 2 x's being multiplied together, x squared. And then negative 32x divided by positive 8x would be negative 4. So far our parentheses match, so that's great. Okay, now out of these 2 terms, I could pull out a positive 12. And you'll see when we do that you're also left with an x squared minus 4. And don't forget to bring down the equals 0, okay? We have to keep it in equation. All right, so now, since all of these parentheses match up, we can take what's in front of the parentheses and group them together as one of our factors within one of the parentheses. And then I'm going to take this common parenthesis that we see and rewrite it just once. And again, do not forget to bring down the equals 0. Okay, if something starts as an equation, it has to remain an equation the entire time. All right, so now we're going to look and see, well, can we factor these further? Now here's a trinomial where a leading coefficient is a 1. So when that happens, we are going to do the AM method. Let's see if we can come up with 2 numbers that multiply to 12 and add to 8. Now, since everything's positive, right, we know that when we set up our 2 sets of parentheses, both parentheses are going to have plus signs. If it multiplies to a positive, they have the same signs. If it adds to a positive, they have to both be positive. So let's put an x here and an x here. And this one's not too bad. 2 numbers that multiply to 12 and add to 8 would be 6 and 2. Okay, now this is dots, right? This is a difference of 2 perfect squares. So if I factor that, that will factor to x plus 2 and x minus 2. And let's bring down the equals 0. And now that everything is fully factored, we can make a t-chart and solve. All right, so here we get x equals, just reverse the sign, negative 6. Here we get x equals negative 2. Again, just reverse the sign. Here we also get x equals negative 2. If you don't want to write it again, you don't have to. And then here we get x equals 2. So even though this was a 4th degree function, we really just have 1, 2, 3 answers. Okay, and the reason that happened is because there is a repetitive answer. So when we do go to graph this, right, if you were to look at the graph, we should have a 0 at 1, 2, 3, 4, 5, negative 6. We should have a 0 at negative 2, and we should have a 0 at positive 2. But what's going to happen here okay? Because there was two of the same factors, two of the same zeros. There's going to be multiplicity. It's going to bounce off the x-axis, okay? So let's graph this in our calculator, see what it looks like, and make sure that we have the right zeros. Okay, I sketched a graph of it, but you can see that, look, like we said, we have a 0 at -6. We have a 0 at x equals -2 with multiplicity, right? It's bouncing off. And we have a 0 at x equals 2. So this checks out.